Okay, so here we have another calculator problem that actually requires a calculator based on the answers. So a race car is traveling on a straight track with a velocity of 80 meters per second when the brakes are applied at time t equals 0 seconds. From time t is 0 to the moment the race car stops, the acceleration of the race car is given by this equation in meters per second per second. During this time period, how far does the race car travel? Okay, so total distance, right? So how far does the race car travel, right? So that's total distance, right? Um, so we want the total distance from t equals 0 to t of whenever velocity is 0, right? When v is 0, right? So here's what we know, right? We know that v of 0 is 80, right? And we want to figure out when the velocity equals 0. Well, velocity is the integral of acceleration, right? So it's the integral of this. So I'm going to get that the velocity is a negative 2t cubed minus t squared over 2 plus c, but I know v of 0 is 80, so v of t, if I plug in 0 for all those t's, I would just get 0, so I'm going to get an 80 for c, right? So this is my velocity. Well, total distance, we then want to know when velocity is 0, right? So there's a couple things going on here. So the first thing I'm going to do is I'm going to put in my velocity, right? So in order to find the time, I need when v is 0. The easiest way to do that is to put this into my calculator because there's really no reason why I would want to bother to calculate this by hand, right? So minus 0.5 t squared plus 80, right? All right, so I'm going to go ahead and hit graph. I'll zoom 6 because this is probably a weird window. Okay, so that's the 0 I want. So second calc 0, right? And I'm at 0, 0. And just keep scrolling over. There it was. Okay, so I'm to the left, cross the axis to the right, enter. Okay, so I'm going to quit out of that. So I get that the time I want is approximately 3.33866162, but I'm going to call that A. So I'm going to quit out of this x and store that as alpha A. Okay, so now that I've called that A, I can say t equals A. Now I need to remember what the formula for total distance is. So the easiest way to do total distance is the integral of the speed. Now, in this case, the car is traveling forward the entire time, right? The velocity is always positive, so you don't really need the absolute value, but to be safe, that's what I'm going to do. So this is the thing I called y1, right? So what I'm going to do now that I've got that A is I'm going to do math 9, right? And then I'm going to go to math, and I'm going to be safe and pick absolute value. Sorry, I want number. There we go. Of there's function y1, close the absolute value, comma, with respect to x from 0 to alpha A. I'm going to hit enter, and I'm going to get that's this. Because again, this was a really multi-layered problem. Like this was a clever multiple choice problem because you had to know how to find total distance. Here, the absolute value really wouldn't have mattered because in this case, the car is constantly traveling forward, right? They tell you it's a straight track, and it's not like the car suddenly goes in reverse, right? It's going 80 meters per second, and then slams on the brake. It's still traveling forward until it stops. So in this case, total distance is going to be the integral of velocity because velocity was always greater than 0. But again, in general, if you have a calculator and you're finding total distance, it should be the integration of the speed, which would be the absolute value of velocity. But before you could even do that, you had to know to integrate to find velocity, and you had to find that other mystery time, which was when velocity is 0. So that was a really clever multiple choice problem. They're not all that multifaceted and that layered. Most of them are much faster, as I think you've seen in these videos.